This is a NEET 2017 question in electromagnetic induction. The question says, a long solenoid of diameter has certain number of turns. At the center of a solenoid, a coil of 100 turns and a radius of 0.01 is placed, with its axis coinciding with the axis of a solenoid. Let me quickly draw a diagram and show you what does it mean, right? There is a solenoid, a long solenoid whose length is much bigger than the radius, whose data is given for you like number of turns. Whatever the data, we will use it as and when required. He said a coil of 100 turns is placed somewhere here. The coil of 100 turns is placed somewhere here at the center of a solenoid, such that with its axis is coinciding with the axis of a solenoid. That means the coil axis is like this, even the solenoid axis is also like this. Both these axes are coinciding with each other. Then the current in the solenoid reduced at 0 to 4 amperes. So what he has done is, he has changed the current in this solenoid. So what happens when current changes in that solenoid? The magnetic field around it also changes. As the magnetic field around it, that is where our coil is there, this coil is there, changes, an induced EMF, current, charge developed in the coil. And you are asked to find what is the induced charge developed in that coil is, when some other data is given for us, right? So hope you understand now what we are looking for actually. What is happening here is, as the current in this coil changes, the field B around it changes. As B changes, induced EMF, induced current and induced charge comes. In this coil placed coaxially, we need to calculate the charge in that coil, right? That's what our aim is, right? So what we can say, induced EMF equal to minus, as there is number of turns, n into d phi by dt. If you consider only the magnitude of the induced EMF, I can write n into d phi by dt. Induced EMF can be written like V equal to like IR n into d phi by dt. Current can be written like rate of flow of charge, dq by dt of R equal to n into d phi by dt. This dt can be cancelled. So dq can be written like this n, that's the number of the turns per unit meter. This R can be, on the other side becomes radius and denominator resistance, and then d phi. What is that d phi is, or change in the magnetic flux is B dot A. That is BA cos theta. But I do say the angle is 0. Why I do say angle is 0 is, the magnetic field and the area of the exposed cross section of the coil are in the same angle. Magnetic field is in this way as the current is passing inside the solenoid, and the magnet and the area of the cross section is also in the same plane. So that is equal to BA itself. That's equal to BA. Where, what is that B? B is magnetic field inside solenoid. Inside solenoid. That B has a formula for the magnetic field inside the solenoid is mu naught Ni, where N is the number of the turns in the solenoid, I is the change in the current in the solenoid, right? So this mu naught is fixed, N is known for us, number of the turns in the solenoid is given for us in the problem. I is the current that is changing from 0 to 4 means current is 4 amperes. Now I know everything, right? So let us substitute in the place of di. What happens to dq? Flow of the charge or change in the flow of the charge is n by r d phi. d phi is BA, but B is mu naught Ni. So N by R mu naught Ni, area of whom we have to take, we are calculating the charge in coil. So area of the coil has to be taken, that is pi r square, where r is the radius of that coil, not of the solenoid. Be careful, solenoid data is not required to solve this problem. Now everything is known, let us substitute the data. N is the number of the turns in the coil, because you are calculating the charge of the coil. That number of the turns in the coil is given for you as 100. By the resistance of the coil is given to you in the problem as 10 pi square, and mu naught is 4 pi into 10 power minus 7. This N is the number of the turns per unit length, unit meter, that was given for us in the problem as 2 into 10 power 4. Current is, it is changing from 0 to 4, so that is 4 by r square. Radius is given for you in the problem as, radius of that coil is 0.01, that is 10 power minus 2 whole square, right? Of course, pi r square, I have forgotten that pi. This 4 is the current, there is a pi, I have to write that pi also. Let us see what can be cancelled in this equation carefully. There is a pi and pi square in the numerator, and there is a pi square in the denominator also, that can be cancelled. This is 10 power minus 2 whole square, that is 10 power minus 4, that can be cancelled with this 10 power plus 4. 1 0 can be cancelled here. So what is remaining? Let's write. In this place there is only 10 remaining. Here what is remaining is, what we have cancelled is actually pi and pi. This 4 is not cancelled, right? So that 4 is there. This 10 power minus 7 is there. This 2 is there. This 4 is also there. They are all the remaining, everything else is cancelled. So 4 4 16, 16 2s are 32. 10 into 10 power minus 7 is 10 power minus 6. So the answer is 32 microcoulomb. So finally you got an answer, 32 microcoulomb. So it looks like a little lengthy problem, but you need to know a lot of concepts to solve this problem. I want you to go through this problem once again and solve it yourself on the paper, so that you will get it right. While you are solving, if you got some kind of a doubt, please ask, so that I will try to answer that. Thank you for watching.